Hi, today we're going to be looking at some demonstrations related to surface tension of water. If you can, try these at home. So the first one we're going to look at is trying to get a paper clip to float on top of water. Easier said than done. It's just regular tap water, and you have to drop it very gently, and then the surface tension of the water actually holds that paper clip up. So we'll be looking at some other cool demonstrations of water's surface tension. So here I have a test tube and some tap water. Colored the tap water green just purely so you can see it better. So if we pour that tap water into the test tube and fill it nearly to the top, you're going to see now what happens as we add drops of water to the top. So we can actually fill this test tube above the top of it, which is pretty cool. So if we keep adding drops to it, you will see that because those water molecules are sticking together, and you want to think about what intermolecular force is the strongest one that's holding them together, because those water molecules stick together, they're able to actually form kind of this bubble on top of the test tube. Occasionally a drop is escaping out the back there. This is not just true of water in test tubes. Here I have a small glass, and if I add water to that full small glass, I'll see that the same thing happens, and I'm looking for kind of that elevated bubble that forms over the top. It's almost as if there's a skin, but it's just the water molecules sticking to each other, and as a result they can build up this bubble across the top of any container that you have. You can see, again, just like the test tube, those water molecules sticking together on top. So now we're going to look at a comparison between putting water droplets and rubbing alcohol. That's isopropyl alcohol. So we're going to put drops of those onto pennies. Don't get too worried about counting drops here, even though your lab manual has a place for you to count drops. We want to more so just observe like how these liquids look different when I put them onto this metal. So hopefully you can see that with the water it is raised up a bit, just like we saw with the test tube, kind of a concave bubble over the top, and there's less of a bubble on the rubbing alcohol. That's telling me that the water molecules are sticking together better than the alcohol molecules are. And you can see how that bubble gets even taller as I add more droplets here. Meanwhile, the rubbing alcohol is fairly flat. That's on the right. Once you hit a maximum, though, now that surface tension is not enough to hold those droplets together anymore. So for our last demonstration, we're going to take some water, take about an equal amount of water. I think it ended up being about 20-25 drops of water onto 2 pennies. So we've got the same water, the same pennies. I think we even got them from the same year, so lots of things are controlled here. And we're going to take toothpicks that don't have anything on them and just show you that the water actually clings to those toothpicks, but the bubble on top of the pennies stays the same. Now we're going to take and put those toothpicks into detergent. On the left was strong dish detergent, on the right is hand soap that's a little bit gentler, and that wraps up our demonstration.